Cool. I'm calling in from Madison, Wisconsin. So on the other side of the river, the other river. Okay, well, you can just get started. So my name is Michelle Mansky. I am the former farm manager at Pillsbury United Communities. And in partnership with Nick and Jennifer and Kat, who are on this call, wrote this grant through the Minnesota Department of Agriculture for a sustainable agriculture demonstration grant. And we had part one on Monday to talk about just sort of like the social aspects of what we were doing. And then tonight we'll be covering more of the scientific aspects. I now work for Savannah Institute, where we work with farmers, landowners, and other stakeholders to mitigate climate change through agroforestry, which is the planting of tree crops. And so this is a photograph of that, one of the farm spaces that we work at. And Mel, if you want to introduce yourself.
Yeah, hi everyone. My name's Mel. I'm the current farm manager at Pillsbury United Communities. So we manage five farm sites in South Minneapolis and North Minneapolis, where we have many partners that Michelle will speak to. And we've loved being able to connect with our neighbors and community members to form different partnerships, to conduct research, build our community, and connect with neighboring businesses and people in our area. So Michelle's going to talk a lot about this research project that she did with Our Savior's Lutheran Church. We've had the opportunity to partner with them to host pizza parties and build on a community farm dream that we share to grow our community.
And feed them.
And feed them with our local produce that is collectively grown.
And then Nick, I don't know if you want to jump in now to introduce yourself. You might as well.
Sure, I'm happy to introduce myself. My name is Nick Jelinski. I'm with the University of Minnesota, and I am a soil scientist. In my lab group, we have a number of projects. One of them is on urban agriculture and understanding the impact of urban agriculture on soil health. And so part of what I think we'll be addressing is the connection between us and Michelle and Mel together, working on better understanding the changes to soil health and kind of under urban agriculture management.
Thanks. And I will do my best to slow down when I get nervous. I just run my mouth. So, so the next slide, please. So this is a very small map of the site that we're talking about. On the left, it is the food forest site that we planted next to Our Savior's shelter, and then just a homeowner on the other side, and across the street there is a school. I'm not sure if you can zoom in on your computers or not, whatnot, but it was just a way to show all the different perennials that we planted in this site. And then on the right is our Earth Day celebration this year. It was very small because of COVID, but we planted a bunch of blackberries, blueberries, rhubarb, strawberries, and some more Nanking cherries. And I think this is a note from Mel.
Sorry about that. Yeah, I just wanted to add that we're working on creating signage to identify the plants that are multilingual with our neighborhood partners who we host pizza parties with. So it's a way to engage the community and increase the educational aspects of the beautiful garden that has been started by Michelle.
And
Steve. And our very amazing and committed community volunteer, Steve, also wanted us to just add a note about how important land ownership is in continuing to grow a vision and a farm into the future, especially when you're planting and farming perennials. And he wanted to congratulate Hoffa for acquiring a piece of land they recently did.
That's awesome to hear. So tonight, we'll be talking about, and you can move on to the next one when you're ready. We'll be talking about the first objective of this grant, which is evaluating the effectiveness of a perennial system to sequester carbon. And that's really due to the permanence of the plants themselves, where we're not constantly taking them out and replanting and tilling, which also incorporates the management practices that promote this carbon storage. So the idea was to switch from a conventional approach to agriculture to a more biodiverse perennial agriculture, which has been shown in some studies to sequester more than 100% of current annual CO2 emissions, which is just mind-boggling and huge. And it's not every study that shows that. There are some studies that show there are no differences. There are some studies that show there are tons of differences. So it's an evolving science. And I think it's going to take a lot of really cool, innovative research projects to figure this out. All that though to say, there's nothing wrong with planting more trees. We can always use more trees. They're so beneficial, and especially if they're edible trees. So that was somewhat of a tangent. I apologize. So the point of this grant, or what we did in this grant, was we evaluated the effectiveness by comparing carbon storage and production systems, this perennial system and annual system, and compared that to turf. And so this is, and looking at the types of organic matter that we added to the soil, which plays a role, and Nick will speak to that a little bit later, in how much carbon you can sequester. And on our site, we were a part of a larger project with many different sites throughout the urban area. And on our site, we used brewer's mash, which is a byproduct of the beer producing process. And we used that because it was free. Breweries love it when you pull up in your little truck and ask to take it away. And we did that. And it also had an added benefit of being super smelly. So it kept a lot of people out of our greenhouses, which was our high tunnels, which was kind of nice. Ready to move on, Kazua. Oh, and I should mention that slide. You don't have to go back, but that was from the University of Minnesota, from Nick's team. They created that slide for us. And so this slide I just wanted to show is from the organization I now work with, Savannah Institute. And it's really showing that planting trees is one of our biggest, planting trees and grazing management systems are our two biggest ways to draw down carbon from the atmosphere, which we sorely need to do. And then you can, and there, it's just sort of interesting looking at the other ways we can do that. So the second objective of this grant was to, in partnership with the University of Minnesota, investigate the impact on these systems, looking at the different soil contaminants and how that changes when you have annual versus turf versus perennial. And it has been showing that soil structure and soil health can decrease the contaminant bioavailability, so making them less available to be taken up by the plants in the systems. Well, I'll wait to say that, but really deep roots and the deciduous leaf fall increase aeration, microbial activity, and formation of organic matter. And so, this has been a 3-year study, which is just not long enough. So we have some results that Nick is going to share, but they're not by any means final. But really what we're learning is that soil health matters. And then this is just an image of Jennifer, who's joined us tonight, and a couple of their interns on their plots that they looked at. And they were growing collards and using different organic matter mulches to evaluate these objectives that I was just talking about. Before I pass it over to Nick, Mel, do you want to add anything? We will talk about how we build our soil and what we've done to the soil on these sites later on in the presentation. But if Mel, you wanted to add anything quickly.
Nope, you can go ahead. Thanks.
Okay. All right, Nick, take it away.
Great. Well, thanks, Michelle, for getting us into it and giving an overview of the work that you guys have been doing. I'm going to give a connection between the scientific data that we've been collecting and the management that's been happening on these sites, which I think Michelle and Mel will continue to talk about more after I'm done. Kazua, is it possible to put or is it Kazua or Michelle controlling the slides? Kazua, can we put the slides back up? Because I think I have some in there. Let's see. What does the next one look like? Oh, great. Okay, so can you go back to the one previous? So Michelle talked a lot about the importance of soil carbon. Obviously, anybody who's a grower, many people on this call are very experienced with the importance of soil organic matter for nutrients, for carbon storage in soil. But actually, soil organic matter is really important for changing the amount of contaminants in soil that are available. And so I'm just going to give a little bit of a background on the one contaminant that we think of a lot in the cities, which is soil lead. So there's elevated lead in most soils in urban areas. And I want to give a little background about how that got there, what we can potentially do about it, and how that connects to the management that Michelle and Mel have been doing. So it turns out that the great thing about soil health is that a lot of times doing the things that make plants grow better actually also fulfill multiple objectives. So if you're increasing organic matter levels or carbon levels in soil, you're increasing the overall nutrient pool available for plants, but you're also increasing the amount of water that can go into the soil. You're also increasing the amount of carbon that can be stored in the soil. And like I'll talk about here, there's a lot of new evidence that shows that if there are contaminants in the soil, when you increase organic matter, you actually reduce the availability of those contaminants. So you lower the risk of actually growing in the soil. So the cool thing is a lot of management practices that build soil health actually fulfill multiple goals, not just plant growth. So can we do next slide? So I'm going to focus on lead, again, only because it's probably the most common soil contaminant that we think about in the cities. There are other soil contaminants. Certainly with urban agriculture, soil contaminants are an issue that we need to be aware of. It doesn't mean that every site in an urban area is going to be contaminated. That's not true. Some sites might be, some sites might not. It just depends on what the historic land use was, potentially. So soil lead is really common in Minneapolis, St. Paul. Just a bit of background on lead and its uses and how it even got into our soils here and around in urban areas around the country. Most common uses are lead batteries, We used to use lead in paint and as a gasoline additive. And the risk to human health is mostly in children, because children, when they inhale or ingest particles that have lead in them, their blood-brain barrier is not fully developed. And so the lead can affect them and lead to learning disabilities, behavioral problems. So when we have high lead in soils, it's important that we know that, and it's important that we understand how to manage those soils to reduce the impact of the lead on human health. Next slide. And this, I just wanted to add why children are more vulnerable. Adults can be vulnerable to exposure from lead in soil, but it tends to be much less because we don't absorb lead the same way that children do. We also don't put our hands in our mouths as frequently as children do. So for children, if they're around soil that has a lot of lead, they're putting their hands in their mouths, and they can ingest more. And because their nervous system's still developing, they're more sensitive to it. So lead in soil in urban areas is really focused on children, although, you know, it's important for human health in general. Next slide. Back one. Oh, okay, one more. There we go. Sorry. Okay, so just to give you a sense of the level of lead that we sometimes find in urban soils, I just drew a diagram to show. So actually, believe it or not, there is lead in all soils. All soil that you could ever measure is going to have some lead in it that is there actually naturally. That lead is there as part of the minerals that make up the soil. So on the left, I have a little blue dot, and it says 0 to 20 ppm. ppm just stands for parts per million. So it would be 1 part lead. 1 ppm is 1 part lead to 1 million parts soil, by weight. That's my little blue dot. So that might be what you would find in a rural area. You might find just some small little tiny traces amount of lead that are there naturally that are not harmful to human health. In urban areas, we typically see much more lead. And the reason for that is people painted their houses with lead paint up until the 30s or 40s, predominantly. A little bit after that, 1930s, 1940s homes and before generally had lead paint. So that lead paint flakes off the sides and can be added to the soil. And then when lead was being used as an additive for gasoline, basically everybody who was driving in the city was spewing out of their tailpipe of their car small little particles that had lead in them. And then in the city where there's a lot of traffic, those little tiny particles fell onto the surface of the soil and over time built up the lead levels in the soil. So what I have in the center and the right show that there's always going to be some little bit of natural lead occurring in the soil. But if you look at, say, the middle of a yard in Minneapolis or St. Paul, chances are it's going to have like 5 to 10 times more lead than you would see naturally. And if you look near the foundation of an old house in Minneapolis or St. Paul, you might see 100 to 200 times more lead than we would expect to find naturally. So that's the reason that it's really important to understand and measure lead in urban soils before we use them for growing agriculture, things like that. Next slide. And you can probably skip again. One more. Okay. So the Environmental Protection Agency has some standards for the amount of lead that's considered safe in soil. Unfortunately, there are no standards yet for what the safe amount of lead to grow food in is. We're getting there, but we're not there yet. The standards that exist are mainly to protect children's health. So they're not really directly related to growing food, but we can kind of use them in some ways like that. So the standards that the Environmental Protection Agency sets are 400 parts per million is the maximum amount of soil, a maximum amount of lead in bare soil and children's play areas. So soil that children are coming into contact with on a regular basis. And we said children are more susceptible to lead. And then for other areas, the EPA standard is actually very high, probably too high if you ask most experts. It's 1,200 parts per million, which would actually be pretty high. But that's the current federal standard. In Minnesota, we actually have a lower, more restrictive standard to protect health and improve the risk of lead in soil. So our standard in Minnesota is actually 100 parts per million, and that was set by the Minnesota State Legislature. So we're required to have 4 times less lead in bare soil and children's play areas than the federal standard says. So we're more restrictive here. Next slide. So I just want to talk about how much lead is in soil. So we can measure the total amount of lead that's in a soil. And then if you flip again, Kazua, only a portion of that is what we call bioavailable. What all that term means, bioavailable, is that if you ate some of that lead, not all of it would enter your bloodstream. Some of it would just pass through you. And so there's a total amount of lead, but then if you ingested it or if a child ingested it, only a percentage of that is actually absorbed into bloodstream. And usually we determine that, my group does not do that, but there's people who determine that in feeding experiments with animals. So we use animals as models for humans in this case. Next slide, you can skip again. So the good thing is that lead is not very mobile. It doesn't move around very easily in soils. It's both good and bad. So once we have lead that gets into an urban soil, it's almost there unless somebody picks up and moves the soil, it's kind of there for life. It doesn't move very easily. There's some things that affect how easily lead can move. And I've got some of those listed there. We don't have to go through them, but it's the normal things that are in soil. Organic matter changes, soil organic matter changes how easily lead can move. The pH of a soil, how much clay is in a soil, other things. But the take home is that once lead is in a soil, it's very difficult actually to remove it. So especially in Minneapolis, St. Paul, when we're thinking about growing areas, a lot of our soils do have elevated lead. And unless you actually move the soil, it's difficult to remove the lead with other practices. Next slide. So soil and gardening. So we know we have some elevated lead soils here in Minneapolis, St. Paul. We know that it's important to measure soil lead before establishing a growing area. And so the big question is, how does lead in soil relate to lead that might be in the edible parts of plants that we would eat? Leafy greens, tomatoes, root vegetables like carrots and potatoes. So generally speaking, makes sense. The more lead you have in a soil, the higher the chance that a plant is going to accumulate more of the lead. But it's very specific to the crop. So it's not, you can't just assume that one plant is going to be exactly the same as another in terms of how much lead it's going to take up. There's a huge range. Next slide. So generally speaking, leafy greens are pretty safe to grow in soil with lead levels less than 300 to 400 parts per million. So most leafy greens will not take up lead in levels that are potentially risky for human health, as long as the soil lead is below 300 to 400 parts per million, generally speaking. Next slide. Fruits. So tomatoes, for example, also tend to be pretty low risk. So those tomatoes I'm using as an example, but most, for example, tomatoes won't accumulate lead in the edible parts of the tomato at soil lead levels that are below 300 to 400 parts per million. So it's pretty low risk to grow tomatoes in even elevated lead, grow and eat them. Next slide. Next slide, I think. Let's see. Oh, there we go. Now the exception is roots. So carrots, onions, radishes, potatoes can actually accumulate more lead in their tissues that we eat. So part of it is they're growing below ground, but also those below ground plant tissues, the roots, tend to accumulate lead more than the above ground tissues. So it's important to know when growing in urban areas, not only the level of contaminants that are there, like how much lead is in the soil, but also what kind of crops am I growing, and how does that match with the level of lead in the soil? How risky is that? Is there a good chance that my crops are going to accumulate lead or not? And it depends on the crop, and it depends on how much lead is in the soil. Next slide. There's not a lot of research on levels of lead that are safe for human consumption in fruits, vegetables, and roots. The UN, United Nations, has tried to come up with some guidelines, but we're just starting to understand what those levels might be. I think, Kazua, on the next slide, I may have some numbers. Yeah. So it really depends on the crop, but these guidelines from the United Nations, if you took your crop and you measured how much lead was in there, there are some guidelines for different crops about what's considered safe or not. Most of these levels of lead are usually, you wouldn't see these unless you had really high lead levels in the soil that the plant was taking up. So most of the time, again, if you're below 300 or 400 parts per million of lead in the soil, generally speaking, the risk for taking the lead up into the crop is low. Next slide. You can skip this one too. Yeah. So things that help reduce, so I said that lead, once it's in soil, it's kind of there. It's there for life. So the lead paint that we had and the leaded gasoline that added lead to our soils in Minneapolis, St. Paul, unfortunately, those soils still have that same lead in them. However, there's things that we can do to soil to change the amount of, to change how available that lead is. So in other words, to reduce the amount of lead that can actually be uptaken by plants and humans. So one of the things, which is awesome for growing food, is compost addition. Actually leads to reduced amounts of lead bioavailability. So the more compost, the more organic matter you have or are adding to a soil, the more you will reduce the risk of the lead that is there, because we know it's there. Next slide. This is a map of lead soil lead in the Twin Cities from a 1989 study. They took 3,000 soil samples from all across Minneapolis and St. Paul to make this map. Basically, the darker areas are areas that tend to have higher lead. And so there's some neighborhoods in Minneapolis, St. Paul that have higher lead than others. So in Minneapolis, most of basically the soils that tend to be a bit higher in lead are kind of South Minneapolis, Phillips neighborhood, Powderhorn. And then in St. Paul, it tends to be Frogtown, Rondo, and Summit, actually. And the reason for that is these are the neighborhoods that have the oldest houses, that had the most traffic when people were using leaded gasoline. So there was cars driving a lot, putting small particles of lead out into the air. They tend to have buildings that are close together. So all those reasons make it so that there's patterns where there's some neighborhoods in the cities that are higher in lead in the soil and others that are less. Even within neighborhoods that are higher in lead, there's a lot of variability. So some properties might have an issue with soil lead contamination, a neighboring property may not. Some of it depends on whether there was a house there, what the land use was before it. So all of this just to say that whenever we're choosing an area to grow in Minneapolis, St. Paul, and we're thinking about the potential for soil contamination, it's important to actually measure on the site how much is there. But there are also these general patterns that we can say, well, yeah, that neighborhood or that area is more likely to have higher levels of lead. So we should be extra vigilant about measuring how much is there, and also the management that we would do when we're growing to reduce the risk. Next slide. So there's definitely ways to minimize the risk. The first is to get soil tested. If anybody's concerned, there are many laboratories that do soil tests. There's also the city of Minneapolis at least had a program, I think it's still going, where you can actually send in a sample and they do it's not quite a test, like a lab test, but it's a screen, and they can very quickly determine whether or not there's really high levels of lead in the soil or not. So what I always tell people who are growing in areas that may have levels of elevated lead, like the sites that Michelle and Mel are growing on, where we know that they're growing in neighborhoods that have a higher risk of soil lead, is that we should get the soil tested. Adding any material to the surface, like compost that we know doesn't have lead in it already, will always help, obviously. If you raise the nutrient levels and the levels of organic matter or carbon, you also reduce the risk of lead. So this is exactly what we're talking about with compost addition or organic matter addition. Anytime you do that, you're reducing the risk of the lead that might be in the soil. If the levels are really high, then usually we tell people to do raised beds so that they can actually build raised beds and fill the raised beds with soil material that doesn't have lead in it. Although I will say I've been to some places where people have built raised beds, but then they filled the raised beds with soil that came from right next to a house foundation. And I remember we were actually at a site and testing the amount of lead that was there, and the lead in the soil in the raised beds was actually higher than the lead in the soil outside of the raised beds. And it was because they had used soil from right next to a foundation that probably had lead paint in it. So it's really important. Raised beds themselves are not a solution. It's the fact that raised beds allow you to put other material into the container that you know is safe. But I think the biggest thing I want to say to connect to now Michelle and Mel connecting this to the management practices is that, again, soil health is great because when a lot of times when we improve soil health for growing crops, we're also improving soil health for things like water infiltration, carbon sequestration, and in this case, reducing the risk from contaminants. So all the practices that we would normally do to improve our soil for growing crops are probably going to reduce the amount of risk from any lead that's in the soil. And I think now I'll turn it back to Michelle to talk specifically about the management.
You have one more slide.
Oh, okay. So this kind of ties into what I was saying. This is some of the research that we've been doing, comparing urban farms to like turf grass right next to the farm in Minneapolis and St. Paul. What these diagrams are showing is basically kind of what I was talking about, where we're looking at many different things: soil carbon, crop yield, water infiltration, phosphorus, things like that. And these diagrams, basically, the longer the pie slice or the cone, it means you get more of that under that type of management. So if you compare, for example, the urban farm diagram on the left to the grass on the right, and you look at water infiltration that we have 3 different depths: 1 foot, 2 feet, and greater than 2 feet. And you can see that the pie slices under urban farms are actually bigger than under grass. So that means that urban management that Michelle and Mel are doing is actually increasing water infiltration. It's helping water get into the soil faster. Same thing with soil carbon. Michelle had talked about increasing soil carbon, and the pie slice is bigger on the farm side than on the grass side. So if you have grass on a city lot and you're mowing it, you're not increasing soil carbon as much as you would be if you were growing food there, which is really cool. And what we don't have on here is related to contaminant risk reduction, but it would be the same thing. If we're adding organic matter to the soil, we have more soil carbon. We're reducing the amount of risk of any contaminants that might be there. And that would be more true under urban agricultural management than under grass. Because under urban agriculture, usually, Michelle and Mel, you guys can correct me and tell me what you're doing, but usually we're adding a lot to a soil. Usually we're adding compost, or in your case, brewer's mash, or whatever you're adding. So there's a lot of intensive management of organic rich amendments going into the soil. Now I'll turn it over to Michelle.
Thanks. Okay. So yeah, at this point, we'll just talk a little bit about the different practices that we were doing on the farm and that Mel has continued to do on the farm, and how we've really been building the soil in this urban environment, where a lot of times the subsoil, or just 2 inches underneath, is class 5 gravel or backfill from building sites. So it's not great soil. And if you were at the first webinar, I talked a bit about the benefits of being so close to so many different businesses. And while I was managing the farms, I really got to be creative with the compost resources. And for me, that was super fun. In this photo, for the Chicago site, the site that our Perennial food forest site that we were showing in the beginning here, I didn't know what was below the soil when I first started. So we had a ton of cardboard in abundance, and a ton of food waste in abundance. Because of the nonprofit that I worked under, there was a food shelf, which those 2 things are constantly coming through the food shelf. So using that, we did a lot of lasagna and layering, garden layering. So lasagna bed gardening, if you're not familiar with that term, it's basically composting in place to create raised garden beds. So you're adding a carbon, which is the cardboard, a nitrogen, which is the food waste, and just layering those on top of one another. And the cardboard really just continued to be a part of our farming practice because of its availability. And really, we had an overabundance of nitrogen from the food scraps. So it's a lot easier, at least in my experience, to come by nitrogen than it is carbon. So this is just a really great relationship that we had that was just right down the road. And then, so next slide. Another example of using what we had in abundance was when we installed this native pollinator and indigenous medicines planting at the coffee shop down the road. We used burlap because the coffee shop owner received all of his coffee shipments in these bags. They're made out of an organic material, and this is what he wanted to use for mulch. So it worked out perfectly. I would recommend putting another layer of wood chips or something, because the weeds did eventually take this over pretty fast, actually. But it was a really great way to use this resource. Next slide. And so on the left is Jennifer and I scooping brewer's mash into the back of my truck. And like I said earlier, it's a free local resource. They were happy to get rid of it. And then on the right-hand side, I called around to several different tree service companies to just see if I could get free wood chips. And in exchange for chocolate chip cookies, I had a service that would drop them off to our sites in South Minneapolis and a service in North Minneapolis. And they would call me because otherwise they have to pay to get rid of it. So that was a really great compost resource as well. Next slide. So each fall we would collect leaves from the neighbors, and that was just a way, because we were trying to do cover cropping, which was a bit of a challenge in the urbanscape, and just for funding. Leaves are free, cover crops cost some money, so we were trying to keep the soil covered year round. And people were super happy to have their leaves picked up. We didn't have to rake, which was great. And it made for really wonderful mulch in the springtime. And I do want to say that there's a note here too, that incorporating this type of mulch, it's a super carbon heavy rich source. So it can tie up the nitrogen if they don't, it can tie up the nitrogen from being available to the plants if they don't decompose properly, or you can add nitrogen in some other way. But really just these resources and being creative where we got them was super fun, like I said, and it helped us jumpstart our composting abilities for little to no cost at each of these sites. Another one, just to help you maybe start thinking outside of the box, is connecting with coffee shops for coffee grounds, or there was a chocolatier down the street. So, I was trying to get their chocolate husks from them, which smells really great. And just really encouraging everyone to be treasure hunters when you're looking for your compost resources. And then next slide. At this point, if Mel wants to add anything, or Nick or Kat, Jennifer, you all are on the call if you want to talk about anything. Otherwise, I think it'd be great to hear about everybody else's experiences building soil. What are you curious about? Let's just have a soil chat. Does anyone want to add anything, or? Sure.
I'll just add, yeah, going off of what Michelle had to say about adding leaf mulch and indoor compost, it's been really beneficial to have so many different additions nearby. So the cardboard, the leaf mulch, and then we've also encouraged volunteers to bring their food scraps to our really large composts as well. So people bring like eggshells and coffee grounds, And then it's a big composting party in the spring.
You hear me? This is May.
Yeah, we can hear you.
Okay. Yeah, I not put on my. I just add a little bit that is that the what I do in my property when summer come in, and my neighbor they cut the grass, and so they put it in a bag and they put it in the yard to the compost site. But myself, I chop the I mow my grass. I leave there on my yard, and so I don't need to put off fertilizer because they already built up that. And so my neighbor they said, "How come you not taking care of your grass, and your grass really long, and us we cut it, we clean really good the yard, but the yard look really dry." And so that is another part. And also when the leaf is falling on your yard, then you just use your mowing, and you just chop that down until you don't see leaf, and so let them sit there through the winter in the spring. And so coming up, and the leaves are rotten into sink into underneath the ground, and so your grass is really nice. That's just, I don't know how people do it, but I do that for my yard for 18 years already. And so that's the kind of benefit for me, and I just get that. And so maybe people know the other way to do that, but I just get that suggestion. That's it. Thank you.
Hi, I'm Christina Elias. So back when I was doing Mashkiki and the Good Juju, I loved the urban farming and being creative, working with neighbors, finding resources. One time though, you have to keep in mind what you're getting and from where, because I did what May said, and I loaded the neighbors a building, and I loaded bags of their grass cuttings, and I was going to mulch all my food beds. And then I realized their lawn had no dandelions, no weeds. So I went over and talked to the yard guy, and he's like, "Oh yeah, we spray every week." So I had to load all those bags back to their dumpster because I would have mulched my plants with grass cuttings that were full of herbicides. So he's like, "Oh, all we use is Roundup. It's no big deal." So when you're working in an urban setting, I also was known to chase down the wood chip truck on my bicycle and do all that. I wondered if you guys, we did mushroom planting. Did you guys work much with mushrooms as a way to clean things?
I have been trying for the entire time I worked there. I was like, we need to do mushrooms. We need to do mushrooms. I really wanted to look at mushrooms and their ability, if they have the ability to uptake the excess phosphorus that happens after composting. Just, you're putting on blind amounts of composting year after year. That was something I was really passionate about. Didn't happen, but maybe Mel can speak to if there are mushrooms in the future.
Yeah, I started this season in June, so it was just like a rush to get everything planted and going. But I think I'd like to experiment with mushrooms in the future. It sounds like, once you get them established, they really essentially take care of themselves. And I think Michelle kind of prepared a bed at one of our sites. So hopefully next year.
I do have a question for Nick, or maybe the rest of the team too. So talking within the framework of food justice and trying to push forward the idea of having more residential homes. Like if you have the capability and the space and the ability to grow your own food, my motto is you should be growing your own food. So really thinking about the research that you guys have showing that, an urban farm actually has way more benefits to, carbon sequestration and all those other nutrient inputs that are coming from just farming or the practice of farming and gardening. So I think, would you say that your study can actually make a good push for policy changes and really allowing people to grow their own food? I'm really talking about my neighborhood with Falcon Heights saying that people are not allowed to grow food on their front yard. And I think it's insane because there is a lot of really, really big front yards in my neighborhood. And so I think that research is so important, not just for urban farming, but also for residential people to understand that when you are growing food for yourself, you're not just doing good for your own body, but you're also doing good for the land. And therefore we as a collective can do good for the world, right? Our whole environment.
The other added benefit of growing in an urban setting is I was able to grow like the most perfect Oneida corn without it cross-pollinating, because in an urban setting, you're not bordered by GMO corn. So people can do some amazing things in an urban setting, but why can they not grow in their own front yards?
I didn't know about it until this summer, and I think it's the case of things not being in plain language until a person of color tries to do it, and then they get in trouble for doing it, and then the government is like, we're not racist, it's been in this language, but it's like, has it really been? So it's always the case of it not really being seen that it's illegal or it's not a good practice until somebody does it, and then people complain about it, and then they try to reinforce it and say that it is that it is an issue for growing vegetation or edible vegetation in your front yard.
Kazua, oh, I'm sorry. Go ahead.
I was going to say quickly, that's where I believe in edible landscaping, where you make beautiful garden beds with flowers and nobody knows all the edible food that's hidden in there. Your kales and lettuce and radishes, and put the flowers around it. And
those are really good points. And Kazua, I think your question is really a good one, because we can measure all these things, but in the end, what matters is, does the data actually get to people who might make decisions based on the data, like policy level decisions? And that's one of the things that we've thought a lot about. I know, for example, that the city of Minneapolis is very interested in increasing water infiltration in soils, right? So is there a potential that growing food could be seen as a way to increase water infiltration, right? So it's not just about, it is of course about growing food and eating that food, that's very important, but there's a lot of other potential co-benefits that are happening when you're managing soils to grow food. And so I think you're totally right. I think there's potentially a large impact that could that is remaining unseen, that could be even bigger if it was better understood how agricultural management influences soil properties, particularly in urban areas. And I think one of the things that's emerging from the data that we have collected is that actually a lot of these urban agricultural systems, not all of them, but a lot of them are actually outperforming grass, right? So a lot of people assume that if you just have turf grass that's been long established, like in a park, and you mow it every year, and you're not touching it, and you're not tilling it, and you're not doing anything to the soil must be pretty good. And maybe it is in some cases, but what we're finding is actually that active management of that soil through agricultural practices can actually improve it. It can actually make it better for a whole wide range of purposes. So I think in my mind, this is a message that is really important that's coming out of our data, is that, hey, let's think about what it means to grow food and think about the value that people are adding by just growing food. And another example of that is we were a few years ago, I was screening a community garden for lead in North Minneapolis. And we actually took cores into the soil. So we would take a core, we go down, drill down into the soil, take a core, measure the amount of lead. And the really cool thing was, at this community garden, they had been dumping materials, compost, I mean, the people that were managing it, compost amendments, things like that to grow food on. But what they had done over a course of 15 years was actually create a rooting zone of almost 10 inches that was contaminant free, that had high organic matter. And once we took a core and went down below, so when we went down below the area they had been adding materials to, we saw that the original surface was actually had elevated levels of lead. So they weren't intending to make the soil safer, but they were intending to grow food. And by growing food and adding all of these amendments over a long period of time, essentially made that lot much safer for the community. And if you were a if you were a municipal agency and you had a lot that you wanted to reduce the amount of lead or some other contaminant on, you would have to pay money to do that, right? So essentially, people, just by growing food, were also providing the service of making this soil healthier and safer. So I think your question is really important, and I think it's something that we hope to address with the data that we're collecting and link that to people who might actually have an interest. Jennifer, do you have anything to add?
So I just added some to the chat about, like, because Steph Hankerson asked, like, will this, like, is this data available for us to share with policymakers? And the answer is, like, yeah, I mean, like, anything you hear from us, like, we're happy to talk with policymakers about, and the folks, so that there's like policymakers who like make policy, and then there's city and county employees who implement those policies. And those two are a little different groups, and they like different information, and they can do different things. Like, if a policy is really restrictive, or it doesn't seem like it has loopholes, sometimes those people who are working in the city government implementing policy can give you the loopholes to take advantage, or can connect you with the people who will sign off. And it's like messy and gross a lot of times, but we want to have policy, or we want to have data to share with these groups and with growers and organizers, to keep pushing for these programs and policies that support urban ag. But it's going to take time. We actually just finished these studies, this 3-year study this fall, and because of COVID, all of our sample processing and all of our data analysis is really far behind, because we can only have one person in lab at a time. And that's true across the university for the most part, at least in our department. And so, like, it's coming, and we're so excited to find out from everyone, like, what works for you in terms of visualizations, in terms of stories, and keep working with y'all.
I see also Fernando had a question about using free compost from the city for building soil, and just questions about, is there a potential it's contaminated? My answer would be no. I don't think it's contaminated. I think it's very safe to use. Most of the municipal sources of compost that we've looked at have basically no contaminants. So those are the contaminant levels that we look at. Of course, there may be some other issues, but generally speaking, those sources of compost are safe.
Yeah, I was just going to add to one of the problems too with the city compost is seeds. You can get a lot of weeds because you don't know where the compost came from. So that ends up being a big problem, is unwanted weeds. So just be aware of that when you're, you might have to do a lot of weeding when you use that compost.
For Fernando and everyone here, I was wondering if we were talking about the compost that you can get and pick up yourself from the city, or if we were talking about the compost that's donated to community gardens and urban farms every year that you have to apply for.
Are they not the same thing? They don't come from the same
Well,
source?
I'm actually wondering because I think that like in the suburbs surrounding Minneapolis, there's like a municipal site that you can just go and pick up.
Yeah, I think that's what Laura. So I think that's Laura, right, Laura? She's using her
Yes,
on
I'm
this phone,
sorry,
but
I'm sneaky.
she's. I think she's asking about those sites, the county sites.
Okay, I was just wondering for clarification because the city of Minneapolis offers free compost to community gardens and urban farms, as well as like educational institutes and nonprofits. But they ask you to go through an application process, and I think it's like top of the line compost that's like composted at a site with high heat to kill weed seeds and all of that. But I only know a little bit about it. So I was just making the clarification. If
Melissa,
anyone wants to add info about that, feel free.
can you share that link, or if you have information, can you share it with me and I can send it out with this after I record this and put it on YouTube? Then I can share that as a resource for our participants.
Yeah, of course.
Thank you.
I think a lot of that compost that Mel was just talking about comes from the Midwakaden Sioux tribe also.
I have a question. I know we're talking about urban farms and urban settings and lead. Do we need to worry about lead in the soils also out in the country because of, who knows, way back in the day, some of the stuff that was dumped or buried, or gas in tractors? Do we think to check the lead in our soils, or is it something do we not need to? I guess that would be a question for Nick, maybe?
That's a good question. I would say generally, no. As we look outside of Minneapolis, I mean, Minneapolis and St. Paul is really where we need to be concerned about it. Once you get even to the suburbs, that risk really goes down. And certainly if you're in a rural area, it goes down. There are some exceptions, like, for example, if you measure soil lead by an interstate, for example, the interstate or a big highway that would have been around, long enough for people to have been driving with leaded gasoline back in the mid-century, you can find elevated levels of lead close to the shoulder, but usually once you get beyond like 5 feet away, 10 feet, it's pretty minimal. So most of your even if you have fields that border a highway, I mean, as long as you're not growing on the shoulder, the chances of having elevated lead are very low out in rural areas. So I would say, generally speaking, unless you have a concern because you know a certain about a certain land use, like if there was an area where there was a dump, for example, or an informal dump that's now being used for growing, then if there's a historical concern or something that you know about, then it's probably worth the investment to get tested. but otherwise I wouldn't spend the money. I think by and large, you're not going to find any elevated levels of lead in rural areas.
Good, thank you.
Is there a difference between lead testing and nutrient testing, right? So when you do a request for lead testing, you're not going to get the NPK data that you would get, or with limesine anyways, but that you would get with lead. So it's two different type of testing, correct?
Yes, and correct. Yes, so correct. They're going to be totally separate. So if you send your soil in for a normal nutrient test, you would also have to request a separate lead test, and it depends on the laboratory, but usually they range from $12 to $18, $12 to $20 maybe for a lead test. And all you get in the lead test is lead. That's it. And you won't get it. You won't get lead if you submit a normal sample for nutrient. I've actually talked to some of the folks at our testing lab. It's an added expense, but I've always thought that people submitting soil samples from Minneapolis, St. Paul, that we should actually do a quick screen of lead that would be included in their report. If you know that it comes from, if you know that the soil is being submitted from Minneapolis to St. Paul, because I do think it's just important for people to know. So I think, and this is going back to the last question too, certainly in urban areas, it's something we want to at least think about. It doesn't mean all of our soils are contaminated. They're not. There's a lot of places that are low and very safe to grow food in. Sometimes even boulevards, surprisingly, we can actually find boulevards that are pretty safe to grow food in. So, but it's really is an issue here in the Twin Cities, and so it's something that people who are sending soil in for testing should at least be aware of. But yeah, it's unfortunately a totally separate test.
And Norm actually brought up a good thought. Like he said that he cover crops with alfalfa. Are there certain types of cover crop that people can be doing? People like grass on their lawn, but what if they're growing like clovers instead of just grass? Or are there certain things that people can be growing to reduce lead, especially if they know that they live in an area that is that can potentially be highly contaminated with lead?
So that's another good question. So the short answer is it's difficult to reduce the amount of lead by just growing plants. And there's two reasons for it. There are some plants that definitely will take up lead. Sunflowers are one. There's some other plants as well that what we call them hyper accumulators. They accumulate a lot of metals. So there's some plants that actually when they grow, they take up metals like lead, for example, out of the soil more than other plants. However, even though those plants take up more metals than other plants, they still don't take up a lot. And so the problem that we have in a lot of our soil is very heavy. And so even like 300 parts per million lead in soil, for example, which would be a fairly like reasonably safe level, it's elevated, but it's not going to be an extreme concern for human health or growing food or anything. At 300 parts per million lead, there's quite a bit of lead that would actually need to be taken out of the soil. And so even if you have a plant that accumulates more metals than another plant, it still is going to take a really long time, many, many years. And some of the research has shown this could be like decades to a century or more. So you might be talking about growing something for a really long time to make an impact on the amount of lead that's there. The other issue with growing plants to take up lead is what you do with the plants. So now let's say you do have sunflower. Let's say you're growing sunflowers, and let's say they're taking up more lead than if you had grass growing there. But what are you going to do with the sunflowers? So if you throw them in your compost and you compost it, lead does not have any, at the temperatures that we live in, lead is only a solid. It's not gas, it's not liquid. So that means that if you get the lead into the plant and then you compost the plant, the lead is now in the compost. It didn't go anywhere. It just ended up in the compost. And then if you reapply the compost to the soil, the lead goes back into the soil. So yes, I guess the short answer is yes, there are definitely things that can be grown to take up more lead than other plants, but to actually use that to reduce the amount of lead in your soil, I wouldn't rely on that. I would rather tell somebody, you know what, if you're going to grow food here and it's a high lead soil, just put raised beds on, fill them with compost or some lead safe material, and that's totally fine. Or if it's not a super high lead soil, but it's like, we know there's some elevated lead, then just keep adding compost and growing food and doing your agricultural thing. Just keep growing food, and actually you're going to reduce the risk from the little amount of lead that's there. So in my opinion, I would rather give somebody that advice, because I think it's safer than telling somebody that like a plant is going to take up the lead, but then not knowing what they're going to do with that plant afterwards, and not having the right expectation for how long that might take. So long answer, short question, sorry.
Thank you.
I just wanted to add a little piece to that, to answer that, not to answer the lead aspect, but Michelle had planted a vetch and rye cover crop at our north side site last season. And when I got there in June, it was flourishing, and there were like thousands of pollinators there that were really, really happy. So it was a neat like color pop in the spring that was also holding down the weeds. And then we were able to incorporate it into the soil as a living mulch. So it added nutrients back into the soil, nitrogen. So I just wanted to say we had success with that. And I know that we got it at Johnny's, I believe, and it's the fall manure mix.
Does anybody else have any more questions? Otherwise, Michelle, you guys can, if you have more things to present on, we have about 13 minutes left.
That's all I had, unless anyone wants to bring anything else up. Thank you everyone for coming tonight. It's been nice to see the crowd. It's been nice to see my Minnesota friends again.
So
Good to
happy
see you,
to
Michelle.
have you. Thank you, Michelle. Thank you for everything.
Thank you.
Thanks, guys.
Well, it sounds like we're signing off, but let's keep the conversation going on other, I don't know whether, what? Mm-hmm.
Oh, you can finish your thought. Was somebody else going to say something? No?
Oh, I just think I had my mic on.
Any closing thoughts for the presenters?
I'm glad to hear there's still the good work being done in urban communities, and I think we should all push for urban farming and urban growth. It's just good for everything on every level, even psychologically to the community, to see that beauty. So hopefully we can keep the good work alive. Kazua, go out and plant something in that front yard. Ask for forgiveness, not permission, girl.
No, you missed our conversation the other day when we talked about how perennial equates to permanence, you know,
Right.
and we're renting right now, so I don't have any intention on planting anything permanent.
Don't do perennials then, just throw down something. The neighbors will follow suit.
Pots. You
I
put them in
do.
pots, you can move them.
I have a bunch of stuff in pots, and now they're in my basement, and my husband's not happy, so.
Like
Yeah.
You know, Doña Rosa, she lives by the Mashkiki and that, and for years her landlord's been telling her she can't plant, and for years she just keeps planting anyway. And she grew corn from Ecuador, and because our lighting is different, her corn from Ecuador went like 2 stories tall and then
Wow.
finally flowered out. But she kept throwing down and composting, and it's just wild.
When in doubt, share your food with the neighbors. I go door knocking to share my zucchinis that I just can't eat all.
I like that you knock people's doors. I just drop food baskets on their front step when I have too much, and I'm like, your problem now, bye.
That definitely has happened to me a few times this summer. Thanks, Jennifer.
Yeah, I've done that with basil. I was like, I'll grow 200 pounds of basil, and then I couldn't even give it away. But we made a lot of pesto for everyone.
Well, thank you everybody for coming and for Pillsbury United and also the University of Minnesota for doing this collaborative work. Thank you community members for showing up, and I want to always encourage everyone to share their voices and their stories and whatever it is that you need, that you're not in this agricultural planting food alone, that there is this huge community out here and we're all working towards very similar things, and I cannot wait until we all can get together and eat together. So you all have a wonderful evening, and stay in touch, okay? Have a good night.
Good night.
Bye.
Thanks. Good night,
everyone.
everybody.
Bye.
Ciao.
Bye.